Hello friends, grab your coffee, grab your cookie, and maybe brush a little sawdust off your shoulders, because today we are talking about wood dust. Yes, the dust that somehow gets into your pockets, your hair, your shoes, and apparently even your lunch if you work around woodworking equipment. My name is Michael Klepik, and I have spent 15 years designing dust collection systems for sawmills, furniture factories, CNC router shops, cabinet makers, and composite wood manufacturers. Today I will walk you through what wood dust really is and how we keep it safely under control. What wood dust really is, technical description. Wood dust is made of fine particles released during sawing, routing, sanding, milling, and grinding of wood. The dust is highly variable depending on the type of wood and the process. Typical characteristics. First, particle sizes range from 1 micron to several millimeters. The airborne fraction is normally from 1 to 50 microns. Second, bulk density varies widely from 70 to 300 kilograms per cubic meter depending on species. Third, typical airborne concentrations range from several hundred to 15,000 milligrams per cubic meter during sanding and routing. Fourth, wood dust contains cellulose, hemicellulose, lignin, natural oils, and in some exotic woods, chemical irritants. Fifth, wood dust is classified as a combustible dust with a low ignition energy. Wood dust seems simple, but technically it behaves very differently from mineral or metal dusts. Hardwood versus softwood versus exotic woods. Wood species dramatically affect dust behavior. Hardwood dust includes oak, maple, walnut, beech, hickory. First, higher density, heavier particles. Second, more irritants, especially from oak and beech. Third, often more hazardous to respiratory health. Softwood dust includes pine, spruce, fir, cedar. First, lower density, lighter particles that float longer. Second, contains resins that can stick to filters. Third, more prone to static buildup. Exotic woods includes teak, rosewood, mahogany, wenge. First, may contain natural toxins and allergens. Second, often produce very fine dust during sanding. Third, some species are strong respiratory sensitizers, so dust handling must adapt to the type of wood used. Why wood dust is dangerous? Wood dust introduces several hazards. First, it is a respiratory irritant, especially the fine airborne fraction. Second, hardwood dust is classified as a carcinogen in long-term exposure. Third, wood dust is combustible and can explode when suspended in air. Fourth, resin-rich dust can form sticky deposits inside ducts and filters. Fifth, dust buildup around motors and electrical panels increases fire risk. Even a thin layer of dust on a hot surface can ignite under the wrong conditions. Physical behavior of wood dust in airflow. Wood dust behaves differently from mineral dust. First, it is extremely lightweight and remains airborne for a long time. Second, it generates static electricity due to friction during cutting. Third, it forms fibrous clumps that can clog filters. Fourth, resin in softwoods causes dust to stick to surfaces. Fifth, very fine sanding dust behaves like smoke and requires high-efficiency filters. To prevent duct buildup, I designed duct velocities from 4,000 to 5,000 feet per minute. What filtration equipment works? Best wood dust requires equipment matched to particle size and production rate. For fine sanding and CNC router dust, I often use a faux-chen cartridge collector. First, it captures small airborne dust efficiently. Second, it provides large filtration area in a compact housing. Third, it cleans well using pulse jet action. For coarse sawdust, chips, and mixed dust, a Baghouse Blizzard is often the best choice. First, it handles large dust volumes from sawmills and cutting lines. Second, it tolerates fibers, chips, and irregular particles. Third, it keeps airflow stable even during high production. For combustible dust hazard, I include, first, explosion vent panels sized for the collector. Second, grounding and bonding of all ductwork. Third, anti-static filter media. Fourth, spark detection systems upstream of shredders or planers. Fifth, isolation valves in ducts. Wood dust safety cannot be ignored. Capture hood design for woodworking machines. The key to wood dust control is source capture. Each woodworking tool requires custom capture geometry. Examples. First, table saws using underblade and overblade capture. Second, edge banders requiring enclosed hoods at trimming stations. Third, CNC routers using multi-point capture directly from the cutting head. Fourth, sanders needing full enclosure hoods because they generate fine dust clouds. Fifth, planers and jointers requiring high air velocities to pull chips effectively. Proper hood design reduces load on the collector and improves indoor air quality. The most common mistakes I see with wood dust. Across woodworking facilities, I repeatedly see these issues. First, undersized airflow that fails to capture fine dust. Second, duct velocities too low, causing fiber buildup and blockages. Third, using filters not designed for resin-rich dust. Fourth, ignoring combustible dust requirements and explosion protection. Fifth, poor grounding, which increases static discharge. Sixth, sharing one collector between wood dust and metal dust, extremely unsafe. These mistakes reduce efficiency and increase fire and explosion risks. What I always do on wood dust projects. My engineering approach includes: first, identifying all wood species used in the facility. Second, measuring dust generation rates for each machine. Third, designing ductwork specifically for lightweight fibers. Fourth, choosing the correct collector type based on particle size. Fifth, adding explosion protection when required. Sixth, using anti-static filter media for sanding operations. Seventh, ensuring all hoods are properly enclosed and positioned. These steps ensure safe, clean, and compliant dust control. Wood dust may look natural and harmless, but it floats easily, generates static, irritates the lungs, and can ignite or explode under the wrong conditions. With proper airflow, custom hood design, and the right dust collection equipment, we can control it safely and effectively. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, wood dust belongs in the collector. Not on your clothes, not in your hair, and definitely not in your coffee. See you in the next video.